let's see if you actually have the key for recursion.org. Let's see if that works. There is so much development to be done. This is why I'm interested in DKI. But let's keep the focus on browsers, why don't we? OpenSSL is great, but browsers don't use it. Internet Explorer uses Crypto API. Firefox and Chrome use NSS. Also, there's no LD preload on Windows. What to do? Well, there's HTTPS proxy. PDP at Gnusis and actually put together a small little application that dynamically generates the appropriate certificates such that on a man-in-the-middle secure proxy session, SSL can be interposed. The way it works is that you basically tell your browser, hey, this proxy, it's got a root cert, it's God, you can trust it, it's cool. Based on the work of Uzuki Hisao and Andres Riancho and Dave Itel. Now what is sent over the wire on a secure proxy link is connect, www.site.com, a port, and then HTTP 1.1. What's interesting is that is enough for us to build what I call Foxy. Foxy is a remote validation proxy for production browsers. So we can provide clients, just as before, a custom root certificate. Before the SSL connection is established, we get the name of the domain the client would like to connect to. For each connection, we can provide a custom root signed certificate. Remember, wildcards don't work nearly as well as they used to. Sorry about that, we broke that last year. The browser will trust us. We, however, will only proxy if the real server passes SSL validation. Now, of course, we're running freeload. So for us, passing SSL validation includes passing DNSSEC validation. And what do we get from this? We get the browser lock in IE out of DNSSEC. And we get the browser lock in Firefox out of DNSSEC. And we get the browser lock in Chrome out of DNSSEC. Not sometime in the future, we get it today. There's a neat trick. Remember no religion? There is something very sneaky we can do once we've outsourced validation. And it doesn't involve DNSSEC at all. In fact, it barely involves DNS. Wouldn't it be nice if we could bootstrap trust with nothing but a domain name? Well, we could have a self-certifying URL. I didn't say it's pretty. You can even put it in front of an IP address. No DNS at all. About 152.151. Now, this would seem kind of strange. I actually based this off of something called the self-certifying file system. Some other guy came up with a very similar idea in 1999. Leo Bernstein did his stuff. Guy gave SFS HTTP, which is what I was going to call it, and his name was Michael Kaminsky, and Michael's my middle name. Weird. There are some scalability issues. Links do work securely, but man, if that cert's ever lost, you lose access to content. But still, it's kind of cool. So at this point, most people think it's time to get rid of the certificate authorities. Oh, no. Actually, it turns out CAs are more valuable than they have ever been. Because in the real world, we have two different things. We have domains, bankofamerica.com, procterandgamble.com, yahoo.com, and there are brands. Bank of America, Procter and Gamble, Yahoo Incorporated. Brands are a closed namespace, meaning if you have Yahoo O or Yahoo Dash, guess what? That's still Yahoo, and a court's going to shut you down. So brands are closed in a way that DNS technically cannot implement, but certificate authorities can, and certificate authorities have. They've come out with a product called extended validation. And what extended validation involves is actual people in actual jurisdictions all over the world saying, yes, this group that calls themselves Bank of America are actually Bank of America. And then you get a green bar, and then you get a thing that says Bank of America Corporation and a country. And this is good. but not perfect. 2008, Adam Barth and Colin Jackson come out with Beware of Finer-Grained Origins. Very nice paper. 2009, Mike Zussman and Alex Sodorov do it 100 times better and basically implement what's called SSL Rebinding. Their basic concept was, hey, if you have a site with an EV certificate, it gets a green bar. But if at time A, content is loaded from the good cert, the big cert, the expensive cert, and at time B, content is loaded from a not so expensive cert that happens to have the same name, the content streams will mix. And you will get attacker content from a bad cert, from a cheap CA, that is going to interfere with the good stuff. And there was no fix. There was nothing that the industry could ever do about it. Till now. DKI actually fixes this issue because of what's called the exclusionary property. DKI is built on DNSSEC, DNSSEC is built on DNS, and DNS excludes. When your DNS domain is registered through eNom, GoDaddy cannot interfere with it, but when your X509 certificate comes from VeriSign, GoDaddy can interfere. It can issue a second cert. DKI by its very nature allows you to not just say, this is good, but this is the only good. If that only good certificate happens to be the extended validation one, well, we're cool. It's good. Nothing else will work. Now, what about the so-called invisible domains? Your average website is hosted from lots and lots and lots of other subdomains. What about those things? How do we deal with that? Zussman and Sodorov actually showed if you break one of the invisible domains, you also get compromised. Well, DKI deals with this two ways. First of all, we make it really easy to deploy SSL even on content distribution networks. If you've got a server with 100,000 domain names, guess what? Your name server can be configured to every single one of those domain names, always return the same hash. So it's always the same cert. It just works fine. SSL just got way easier and cheaper to deploy. You want SSL everywhere? You make SSL 1/10 the cost of actual operational deployment. Second, exclusion works for those invisible domains as well. So once you have those 1,000 hashes in DNS, if a random CA goes ahead and tries to throw its stuff in, none of them work. Before we finish, don't stop me. I'll go no more than like 2 or 3 minutes over at worst. Before we finish, I do believe we promised to do something about email. Anytime I talk about email, everyone loves PGP. Fine. We'll go ahead and patch DNSSEC into PGP. So we're working on a package called FreeGP. FreeGP ports end-to-end DNSSEC lookups to GPG. This is what it takes to do it. Echo, foo, pipe, GPG, no default keyring, temp, GPG, random, encrypt, armor, auto key, locate, PKI-R, test at pba.org. If you were to type that in on the modified GPG engine, you will, in fact, get 0 prompting, 0 notification. It'll look up the key, it'll validate it by DNSSEC, it'll encrypt, and it'll be great. Why am I not showing you Thunderbird right now? Because, man, GPG does not want to be secured by DNSSEC. Among other things, you know PGP certificates don't actually name the email address that they're signing for? Now, I'm sure, John, that there's some very, very good reasons why this is the case. But let me tell you, when I see a signature, I can read it. You know what I'm reading? The person's name. This is not supposed... What, we're back in the days of X? So this is, for all sorts of technical reasons, it's a really big pain in the butt. In order to actually get this working, deep work is going to be necessary, either with the NIG mail or with like the PGP desktop stuff. Now what about DKIM? DKIM is kind of neat. DKIM is a way of putting not actually a certificate, but a public key in DNS. And it is a way for 2 mail servers to identify one another. To say, oh, okay, you're sending me this message, and I know that you're actually sending a message for yahoo.com because you've signed it with the Yahoo key, and I looked up the Yahoo key in DNS. If there's anything that you would think would be perfect for DNSSEC to help, it's DKIM. Well, you know, there's a little problem with DKIM. There's absolutely no user interface to it in the world right now. Maybe there could be, but as a note, DKIM has no facility to authenticate not merely the mail server, but also the user at play. DKIM just doesn't do that. Right now, it is fundamentally an anti-spam system, not a replacement for generic secure email. So what else could we do? SMIME. SMIME is very interesting. You know, doesn't exactly have the coolest reputation out there, but it is actually the most widely deployed secure email system on the planet. It is in Outlook, which means it's in pretty much the entire Fortune 500. It's in Thunderbird. It's not in Gmail. The Gmail plugin doesn't do signature verification. If you don't do signature verification, I'm not talking to you. But SMIME has key management problems. Like everything built on X509, certificates have key management problems. It's not its fault. The big thing that really kills SMIME is lack of exclusion. You yourself may build a company that has the world's greatest key assignment system. Man, if you want a certificate from them, you have to go in, you have to like prick your finger and deliver blood before they'll give you that pack of bits. Okay, that's cool and all, but the other guys that are just to do a DNS lookup, they can go ahead and issue a certificate too. And when they issue an email certificate, it looks just the same to everyone else on the rest of the internet. So it's the problem we had with SSL search for browsers, 100 times worse for email clients, and ultimately very few places have actually deployed the technology. So can we fix this? Like literally, like can we? Do we have the technical means? We were able to hijack OpenSSL because of LD preload. We're able to hijack the browsers because they have a piece of proxy functionality. How are we supposed to hijack Crypto API? I mean, it's got an extensibility point for rejecting certificates through its revocation engine, but it does not have a way to say, I want to write a plugin that accepts certificates. Now, maybe I could write like a custom Outlook plugin, but that stuff's really undocumented. There is another trick, but it's way too hideous to talk about. Guess we're hosed, right? So, who here can recognize this astonishingly bad idea? No one? Aww. So, there's this thing in, especially the Windows world, called API hooking. It is normally used to cheat at video games. Oh yeah, we're hooking crypto. We're hooking crypto in Outlook. So we're putting together a package called FreeGP, DNSSEC validation for Crypto API. Crypto API has a function called CertGetCertificateChain. If it returns true, the chain is valid. What's really cool is that you can inject code in anything and say, hey, I want to be called when this application calls CertGetCertificateChain. If you debug your injected function, you actually get like full debug symbols just for where you are. It's like, I don't care about the rest of Outlook, but right here at this line of coding, you're like, oh, okay, so here's pcert info and subject and algorithm and public key and issuer unique ID. Okay, I'm not usually a binary guy. This is awesome for me, so give me a break here. So here's the demo. And this is the last demo I want to do, and I wish I could do it live. We have a signed email here from dan@thebank.org. You can tell it's signed because there are 16 pixels that put a nice little award on it. But it's signed. Suppose we go ahead and we use this actual tool normally used to cheat at video games, remote DLL. What if we go ahead and we inject our code in that adds DNSSEC checking to Crypto API? What happens? Bam! Doesn't work anymore because we didn't know. We only put in the checker. We haven't actually put in the DNS records yet. So what do we do?